Factoring trinomials, part 1. This is factoring trinomials of the form x squared plus bx plus c. Now remember from the previous sections, what does factoring mean? Okay, factoring means that you're going to rewrite a polynomial as the product of other polynomials. So far, we have one step that we've looked at in factoring, and that is finding the greatest common factor. Okay, let's look at problem number 1. All of the directions for these problems on your homework will just say factor. Okay, it will not necessarily tell you which method to use. Okay, so that's why it's important here in the beginning that you can identify what kind of problem we're looking at. Okay, we said factoring trinomials. So I have a trinomial that has 3 terms. My very first step should still be, is there a greatest common factor? Well, as I look at those 3 terms, there's nothing that will go into all of them. So we don't have a GCF. Now I want to try to break down this trinomial as a product of 2 binomials. It's kind of like the opposite of the FOIL method. When we were multiplying 2 binomials in the previous chapter, we used the FOIL method to get a polynomial answer. Well, now we want to go in the opposite direction. I want to know first what should go in the first 2 slots in my 2 binomials. Those 2 terms always have to multiply to equal the first term in my trinomial. Well, what's going to multiply to be x? Well, our only choices would be x times x. Then I have to look at what terms will go here. Okay, this is the really the factoring part of this whole section. If I look at the last number, positive 36, I want to find the factors of 36 that will also combine to give me the middle term. Okay, this last sign in my problem is very important. Okay, this is a positive 36. That's going to tell you that you want to find 2 numbers that will add to give you the middle term. Okay, so if I make a list of my factors of 36, it could be 1 times 36, 2 times 18, 3 times 12, or 4 times 9, or 6 times 6. From that list, I also want the numbers that are going to add up to be positive 13, which would be 4 and 9. So in my answer, I'm going to have 4, 9, doesn't matter the order, and they will both be positive. So my answer would be x plus 4 times x plus 9. Now I can check this if I want to by using the FOIL method. If I check, first would be x times x, x squared. Outer would be x times 9, 9x. Inner would be 4 times x, 4x. And last would be 4 times 9, which is 36. And when I combine like terms, I would get x squared plus 13x plus 36, which is the polynomial that I started with. Okay, you can always check your answers on these. The answer must multiply back to equal the exact polynomial that you started with. So as I look at my problem, I notice I have a plus and a plus here. If my signs are both positive, then they will both be positive in my answer. Okay, let's look at number 2. X squared plus 11x plus 30. Again, there is not a common factor. I want to break this down into 2 binomials. If it begins with just x squared here, you will always have x times x. Look at your last number, your constant, positive 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. I want the factors that are going to multiply to be 30, and because it's a positive 30, it's got to add to give me the middle term. Okay, so what's going to add up to be positive 11? Well, it would be a positive 5 and a positive 6. So my answer would be x plus 5 times x plus 6. Now again, it does not matter the order that you write your answer in. I could write x plus 6 times x plus 5. Okay, it still means exactly the same thing. Okay, let's look at number 3. Y squared plus 7y plus 10. Again, there's no common factor. If I begin with y squared, it means I would have y times y. Look at the last number. It is positive. That means I want to find two numbers that will multiply to be 10, add to be 7y. So I have to look at the factors of 10, 1 times 10 or 2 times 5. Now you don't have to always write your list down over here on the side. You know, if you can do this in your head, that's great. Okay, but what's going to add up to be 7? 2 and 5. Again, both positive. So my answer would be y plus 2 times y plus 5. Okay, I want you to pay, again, great attention to what's common between these three problems. In all of them, the constant, or the last number, was a positive. Okay, so I had a positive 36 here, positive 30 here, positive 10 here. Okay, when that last number is positive, your two signs in your binomials will always be the same. Okay, here they were all positive, and it's because this middle term was positive. Okay, in the next video, we'll look at what happens when the middle term is a negative number.